Okay, so these two examples here are using the compound and double angle formulas. So the first one that we can look at here, we'll look at 9. So we've got sine of x equals negative 0.8, and we've got a domain here for x. Now what this domain tells us, I'm just going to draw a little picture here, is that we're in between pi and 3 pi on 2, so that's that region there. Now we know from this picture that sine in that area is going to be negative because it's below the x-axis, and cos in that quadrant will be negative as well. So that helps us just understand what sine and cosine will be. So you can see here that we've got sine x that's given to us, and we're looking at sine 2x. Now what I would tend to do in that situation is go and look at my double angle formulas, and you can see here that the double angle formula we'd be most likely to use is this one. It has a sine 2x in there, and you can see also that you need sine and cosine. So I'm just going to put that formula in here. Okay, so that's the one we're going to use to help us with part A. So sine 2x equals 2 sine x cos x. So now what we can do, we know what sine x is. So sine x equals negative 0.8. We need the cos x, and we know that that link between sine x and cos x is that classic Pythagorean formula. Okay, now we know what sine x is, negative 0.8, which we could square, and then we could solve for cosine squared of x. Now that's going to be 1 minus 0.8 squared, which is 1 minus 0.64. And I can tell you that that would be, actually on the next line, we'll solve it for cos x. So taking the square root of that, that's going to be the square root of 0.36, and that is going to be plus or minus. Now the key with this, because you're doing a square root of both sides, you have to remember which sign it will be, and it will be a negative because cos is negative. This will be negative 0.6. So we now know that cos is negative 0.6. So for the first part of this question, for part A, we wanted sine 2x, which we know from our formula is 2 sine x cos x, which in this case is going to be 2 times sine x, which is negative 0.8, times cos x, which is negative 0.6, and after all of that you'll end up with 0.96. If you multiply those through, it's positive because the negatives cancel each other out. The next question that we're looking at is part B. So if we look at B, you can see we've got cos 2x now that we're after. So again, what I would do is go over and look at my formulas, and I can see the one that has cos 2x is really any of these ones here. There's quite a few variations that you could use. So I'll put those here. And to be honest, you could really use any of these options here. I'm just going to use, well, I know I've already found what cos squared x is, which is 0.36. So I'm just going to use that one. So cos of 2x, if we put our values in there, what you're going to end up with, I'm going to just put 2 cos squared x minus 1. So I'm using this one. So I've got equals 2 times, I know that cos squared x from over here is 0.36, and take away 1. And what you'll find if you do all of this work, you're going to get 0.72 minus 1. So that will end up being a negative number, negative 0.28. And that makes sense because we were kind of expecting that the cos would be maybe a negative, but not necessarily the cos of 2x. So it's worth really checking back with what you started with. So that's the idea here with this one. So using your formulas, first of all, to find what cosine is, and then using your double angle formulas to try and help you. Okay. So the second question that I had for this one is here. So we've used the double angle formula for question 9. Question 5, we're going to use the compound angle formulas, and it says use the compound angle formulas and appropriate angles to find the exact value for each of the following. Now you can see that pi on 12 is a non-standard angle, so what we need to do is try and construct that pi on 12 by using standard angles. So by using, pi on 2, pi on 3, pi on 4, etc. So usually with the pi on 12, it's going to be some kind of mix of pi on 3 and pi on 4, and I tend to just try various, options with that. Pi on 12 is quite small, so the one that I might try is pi on 3 take away pi on 4, and if I make both the denominators the same, times the top and the bottom by 4, and then times the top and the bottom of the second fraction by 3, you can see, awesome, you end up with pi on 12. So what that means is that this particular question, I'm just going to change colour, is sine of pi on 12, which is actually exactly the same as sine of these two angles, one, minus the other. So two angles, one minus the other. And if we were to simplify them down to something you know. So that's pi on 3, and that's pi on 4. Okay, so you can see you've got your two angles there. Now what we want to do is we want to try and figure out how to work with this. Now this is going to be compound angle formula. We've got two angles inside the sine, and if you have a look, we've got sine x plus y and sine of x minus y. It's going to be this one because we've got two angles, one take away the other. So if we put that formula back here, you can see that's the formula we're going to use. And in our case, it's usually a good idea to write down the formula you're going to use and then say that in this case x is pi on 3 and y is pi on 4, because the order actually is important here for what's happening inside the sine. So we've got sine of pi on 3, take pi on 4, equals, and now we just fill in where x is, we put a pi on 3, and where y is, we put a pi on 4. Minus cos of pi on 3, sine of pi on 4. And we know that sine of pi on 3, if we think about drawing with triangles, I'm just going to get rid of this side here, because we've already seen that question. If we think about using triangles, we know we've got a half, we've got pi on 6, pi on 3 up this side, root 3 on 2, 1. So we know that sine of pi on 3 is the opposite side, so that's root 3 on 2. Oops, do that again. Root 3 over 2. Cos of pi on 4 is that other nice triangle that you have, root 2 on 2. So both sides are root 2 on 2. So this is root 2 on 2 minus cos of pi on 3 is the other part, and sine of pi on 4 is the same. So if you wanted to make that nice, what you could do, I'm just going to write the answer up here. We've got root 2 times root 3 all over 4 minus root 2 all over 4. So what we could do is to factorise that. So to finish off, sine of pi over 12, which is what we were finding, is I'm going to take the root 2 over 4 outside because it's common, and that leaves root 3 minus 1 inside the bracket. So what you've done is you've broken up an angle that's non-standard into two angles. Now if you do have trouble working this way, what you can do is try and work with like a pi over 12 take away b pi over 12, and then experiment with what a and b has to be, and to make, you want to try and make a 1 on the top line, so you could do 6 pi on 12, that would be pi on 2, minus 5 pi on 12, well, that's non-standard. You might do 4 and 3, 4 pi over 12, and 3 pi on 12, and that's what we ended up doing. So, and we were able to find that that was pi on 12 and that turned into two nice standard angles. So work on it that way if you're having trouble finding the pair. So split your angle up into two angles. It may also be adding. So often the angles where you have, another number on the numerator are added as well. It doesn't have to be subtract. And then once you've found that, all you need to do is use your compound angle formula, so either the one where you're adding the angles or subtracting the angles, and then just substituting your values in. At the end, you just want to simplify it, so try and factorise if you can. So that's using the compound angle formula to find the exact values for what we would call a non-standard angle. So a very, very useful technique.